Hello all, we are in the module 4, that is CAMS. So already I have shared the introduction part. So today we will see the first numerical problem to how to draw a CAM profile. So before going to this problem, just recall the basics what you studied in the introduction video. So coming to problem number 1, see this question. A CAM with 3 centimeters minimum radius is rotating at clockwise at a uniform speed of 1200 rpm, has to give a motion to a knife edge follower as defined below. Follower to move outward through 3 cm during 120 degree of cam rotation with SHM. Dwell for next 60 degree. Follower to return to its starting position during next 90 degree with UARM. Dwell for remaining period. So draw the cam profile when the axis of the follower passes through the axis of the cam. Also find maximum velocity and acceleration during the outward and inward stroke. So whenever you want to draw a cam profile, the problem consists of two parts. As I already said, to draw a profile we need two things. There are two steps in the problem. First is to draw the displacement diagram, and second is to draw the profile with the help of the displacement diagram. So data required to draw these two will be given in the question, so we have to analyze that first. Okay, so see the question. A cam with a 3 centimeter as the minimum radius. So minimum radius, this is nothing but the radius given for the base circle. So while telling about the terminology, I told about the base circle. It is the circle which defines the size of the cam. So that circle radius is given 3 centimeter. So this will be helpful to draw the profile. That is the second part. We'll see that later. It is rotating in the clockwise at a uniform speed of 1200 rpm to give motion to the knife edge follower. So whatever data given initially, all these are required for the second part of the problem. Now see that sentence, give motion to the knife edge follower. So our type of follower is knife edge follower. You can see here knife edge follower. So that is very important. Identify what type of follower is that. So here it is knife edge follower as defined below. What is defined below? He is defining the motion of the knife edge follower. Okay, motion in the sense displacement, how much it is moving from one point to another. Okay, so that is defined in the question. So first one, A, follower to move outward through 3 centimeter. Okay, what is the meaning of this follower to move outward? Outward means this outward is given, the word is given with respect to center of the cam. Okay, it is moving outside with respect to the center of the cam. So moving away, that means if it has to move away, it has to move in the upward direction, correct? So follower moving in the outward direction means it is going upwards. What is the distance? Through 3 centimeter. Okay, it is going up to 3 centimeters. So they are given the distance of movement from the initial point. It will move up to 3 centimeter. Okay, so 3 centimeter till where? Okay, till where? During 120 degree of cam rotation. What is the meaning of this 120 degree? So we already know that one complete circle of the cam means 360 degree of rotation, correct? So complete rotation means 360 degree. Out of that 360, first 120 degree, okay, during the first 120 degree of rotation, the follower is moving upward to a distance of 3 centimeter. Okay, only for 120 degree, first 120 degree. Okay, that is still here of cam rotation with SHM. What is SHM? I told you about different types of motion. So in that, SHM means simple harmonic motion. Understood this statement? So follower is moving outwards, that means moving upwards to a distance of 3 centimeter for first 120 degree with the motion type is SHM. Okay, that is the first statement. Next, B, dwell for next 60 degree. What is the meaning of dwell? Dwell means constant. Okay, no movement at all. So dwell for next 60 degree. So 120 degree is already told. So next 60 degree, for the next 60 degree of cam rotation, it is constant. The follower will not move at all. So it's a constant. So how much is completed? 120 degree first, then 60 degree. So total 180 degrees over. Okay. Next C. Follower to return to its starting position during next 90 degree with UARM. Okay. What is the meaning of this? C. Follower to return to its starting point. From where it started? Okay, in the first point it was moving outwards, so away. So now it is coming back to that original position, return to its starting position during next 90 degree. So 180 degree is over, first 2 points. Next 90 degree, okay, remaining 90 degree with the UARM. What is UARM? Uniform acceleration retardation motion. Okay, so next type of motion, UARM. Last one, dwell for remaining period. Dwell means constant for remaining period. What is remaining? So 120 plus 60 is 180. 180 plus 90 is 270. So remaining 90 degree it is constant. Okay. So this A, B, C, D points are given. This defines the displacement of the follower, how it is moving. So these 4 points will help us to draw the displacement diagram. The first part of the problem. Okay. Second part we will see later. What is this? Draw the cam profile and the axis of the follower passes through the cam. Okay, so first drawing this displacement diagram. Okay, so don't just go on seeing the video, preferably draw along with the steps explained here. So there is no need of a graph sheet to draw this. You can draw this just in the plain sheet. Okay, so first we will draw the displacement diagram. Okay, so displacement diagram, what is required to draw the displacement diagram? So displacement diagram, as already told in the introduction part, it is nothing but the diagram which indicates movement of the follower. So there are two axes, x-axis, y-axis. X-axis defines the degree of movement. Okay, what is the rotation, degree of rotation cam has traced? How much is, what is the rotation? It is complete 360 degree rotation. Okay, so complete 360 degree. So we have that will come in the x-axis, whereas in the y-axis it will be the displacement, or the other thing but the stroke. Okay, how much movement has taken place? Here the maximum movement is 3 centimeter. Okay, follower can move up to 3 centimeter. That is our stroke length. Clear? So draw this box first, which defines the x-axis and y-axis. Now x-axis 3 sorry, y-axis 3 centimeter you can draw easily. That will fit in your book. Whereas the degree, can you draw a degree? It is very difficult. We can't directly draw the degree here in y-axis, the x-axis. So we need to convert that degree in terms of linear scale, that is centimeter or mm. Okay, so first draw the, so first write the scale. So write the scale. So here the scale will be taken as 20 degree will be equal to 1 centimeter. So if you draw 1 centimeter, that is equal to 20 degree. So always write the scale first. So draw this in your book. Scale 1 centimeter is 20 degree. So follow the scale now. So once you understand, you can take your own scale and draw it. Okay, 1 centimeter is 20 degrees. So keep this aside. So it should be there in the top. You know what is the position of the scale. Then draw the x and y axis. So first the 30 degree y axis, which defines the stroke length. Then y axis you have drawn. X axis. So 360 is converted to the scale, so 360 will be 180 mm or 18 centimeter. Okay, so that is drawn. So this type of box you have to prepare. It will be a rectangular box, x-axis with the degree representation, y-axis will be the stroke representation. Okay, so now after drawing this, we have to divide this box into different parts. So the parts will be the indication of the angles mentioned in the problem. So in the problem first part, the curve, the outward movement taking place at 120 degree, then dwell for 60 degree, then again return at 90 degree, then dwell for remaining 90 degree. So that angles should be marked on this y-axis. So division has to be done. So that division I'm doing here now. So first is 120 degree. So according to the scale, what is 120 degree? It will be 6 centimeters. So mark that line at a distance of 6 centimeter, but don't write 6 centimeter, write the angle. Okay, so next is 60 degree. According to the scale, 60 means 3 centimeters or 30 mm, that has to be marked. Next one is 90 degree. So this is 60 degree. Then 90 degree. According to the question, the C, the inward movement or the returning to the starting point, it is at 90 degree. Write all those angles. Okay, first is 120, next 60 and 90. Okay, angles. So this is how you have to divide the box into different parts. So angles are given in the question. According to that, you have to divide. Now first one is 120 degree. So we will just concentrate on that now. So first one is here SHM. The steps when SHM type of motion E. So whichever section has SHM, first divide that into minimum of 6 parts. You can divide into more number of parts. So here 120 degree section has SHM type of motion. So first divide that into 6 equal parts. That is the first step whenever you have SHM type of motion. So name that accordingly 1, 2, 3, 4. You can start from 0 also. So first one is 1, next 2, next 3, 4, 5 and 6. Okay, 6. You can divide into 8 parts, 10, 12. There is no restriction for that. So if you divide more number of parts, you will get more accurate profile. That's it. So make a habit of dividing into minimum of 6 parts. Second step is draw a semicircle at any one of the side of the box. Okay, you can draw on this side or on this side. Okay, on any one of the side, draw a semicircle from the center point. Okay, so 3 centimeter is the height here, so 1.5 will be the radius. So draw a semicircle. So once you draw the semicircle, divide that semicircle also into same number of parts. So here you are divided into 6 parts. So same number of parts you divide this semicircle also. Okay, so 6 parts it has to be divided, equal 6 parts. So 180 by 6, 30 degree each. Okay, so it will be equal number of parts. So draw the lines from respective points. First I will name that ABCD, that will make you clear. So first point, name it as alphabets. Okay, A, then B, C, D, E, and last one F. If you have more points, go on naming with alphabets. So it looks like this. So from A, draw a line to 1, from B to 2, C to 3, D to 4, E to 5, and last F to 6. It's already there. Okay, now this intersection point, what you get, name that as 1 dash 2 dash. Okay, alphabet, the numbers with the dash. So this intersection point, that is very important for us. 1 dash 2 dash 3 4 5 and finally 6. So these intersection points are very important. Now starting from 0, join all these intersection points, not with a scale, just freehand joining. Join all these points. So this is the displacement curve for the first movement, that is the upward movement of the follower. So we have completed that 120-degree. So next is that part is over. Second is dwell for next 60-degree. So it is just constant. So now curve has reached till point 6 dash. So there you just draw a straight line for that particular duration. For the 60-degree, you draw a straight line. I'm just indicating the red color so that you can differentiate the curves. Sorry. So the 60-degree we have completed. Next we will go to the 90-degree part. So they have told that it is coming back to the starting point with a 90-degree duration with UARM. So when you have UARM, first step in UARM is similar to SHM. Divide the section into equal parts, that is 6 parts, equal 6 parts. Okay, how you are divided in SHM, similar way divide that here also. That extra lines, remove it, not required. Only inside the box you have to draw a line. So remember, it should be equal 6 parts, not random 6 parts. So while numbering here, it should be in the return order because the curve has already reached sixth point. Okay, so we have to name that in the reverse order, not 1 2 3. It will be 6 5 4 3 2 1. Okay, so first point will be 6 here, next 5, because it is returning. So curve is already at the topmost position, the follower at the topmost position, so it has to come back. So 2 1, last one is 0. You can write 0 at the first point. So next step is, in this 6 lines, select the middle one. Now out of this middle line is third line. Okay, so 1 2 3, 1 2 3 parts on the either side. Select the middle line, divide this middle line into same how much you are divided here, 6 parts you are divided. Divide this line, the middle line, also into 6 parts. Okay, equal 6 parts in the upward direction. So in this way you have to divide. Small line you can draw, or the one point which just indicates the division of this line. Okay, equal 6 parts. So if you divide 8 parts, this is also you have to divide into 8 parts. Now only 6 parts are there, so divide that into 6 parts. No need of writing any dimension. Okay, so divide like this into 6 parts. Small line is enough. So these points what you have marked here, name it with the alphabets A B C D. Okay, from bottom A B C D, name it in that way. So first point A, B, third one is C, D, E and F. Okay, now after drawing this, so again you have to divide into two parts, top three parts, bottom three parts. So first point, the whichever point, the starting point or end point, whichever is nearest to these 3 points, join those 3 points to starting and end point. First three will be joined to the end point, last three will be joined to the starting point. So like this, first point to ABC, last 3 points to DEF, in this way. So line from A, where it cuts the line 1, that will be 1 dash for us. Okay, you can see here there is a line from A, it is intersecting on the line 1, so this point. Okay, that is our intersection point, so name that as 1 dash. So like this. So this intersection point, line from A and 1, so that is 1. Now line from B and second line, so this is the point, so that is 2 dash. Next 3 and C, this is the intersection point, 3 dash. 4 and D, this is the intersection point, 4 dash. 5 and E, this is the intersection point, so 5 dash. And last 6 and F, this is the intersection point. So this way I have to name. Now join all these points, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, whatever the points you have marked, join all that with just a freehand curve, not with the scale. So this is the return curve. The curve is coming back to the home position. The follower is coming back to the home position. So this way you have to join all that intersection point. This completes the second type of motion, that is UARM, the return stroke. Okay, so last it is dwell, so just continue the line constant. So this is how the displacement diagram is drawn. Okay, so now this curve is very important. So any problem, first you have to draw the displacement diagram, so that is very important here. So this is how a displacement diagram looks. Next we will see the second part of the problem, that is drawing the cam profile. So we need this displacement diagram to draw the cam profile. So we will move to the cam profile, second part. So before starting the cam profile, main thing required is a base circle radius. As I already told, base circle radius given in the question is minimum radius, the first line 3 centimeter. Okay, so draw that circle first, 3 centimeter, that is very important. Now in the question he has told that the it is a radial follower. The axis of the cam and axis of the follower is the same line. So draw this vertical line from center to the top. Place the knife edge follower. The type of follower told here is knife edge follower. Draw a knife edge follower at the tip. Okay. Now next step is very important. So in the question it has been told that the cam is rotating in clockwise direction. Okay. So whichever direction is given, we have to move in the opposite direction to divide the circle into different angles. Okay, so in the question it is given clockwise, so we have to move in anti-clockwise direction and divide the circle into different angles. What is that angle? Angle is nothing but the 120 degree, 60 degree, 90 degree, 90 degree, what is given in the question. That what you are divided in the displacement diagram, those angles has to be marked here. Okay, so since it is given clockwise, we have to divide the angles in anti-clockwise direction. So whatever direction is given, move in the opposite direction. So first angle is 120 degree, so I'll mark that 120 degree with respect to this line. Okay, this with respect to this vertical line, draw angle, draw line at angle of 120 degree. All these things you have to do in a book, not in a software. So and this angle is 120 degree. Okay, so first part 120 degree, second is 60 degree, it is a dual, so mark that 60 degree here. Now 60 degree will be this line with respect to this line, from here 60 degree, not from the starting point. Okay, from here 60 degree. So first one 120 degree. So see here, it is how, this is how it looks. Next 60 degree, draw a line, mark the angle 60 degree. Next part is 90 degree. Follower is returning to the starting position as given in the question. So mark that 90 degree. Okay, so after dividing this into different angles, we will go to each section. Now first 120 degree. Okay, so this is how many parts we are divided in the displacement diagram. We have divided that into 6 parts, correct, in the displacement diagram. Same number of parts you divide here also. Okay, 120 degree you divide into same number of parts how much you divided in the displacement diagram. So there you are divided into 60 parts. So divide this 120 section into 6 parts. So 120 by 6, 20 degree each, so like this. Okay, write this and the tip, write the number. So this will be 1, next is 2, next 3, 4 and 5 and 6. So 6 points. Okay, so dividing this section into 6 parts. Next 60 we didn't divide into any parts in the displacement diagram, so here also we are not going to divide, but 90 degree we have divided into 6 parts there. So same thing you do here also. This 90 degree you divide into 6 parts. So 15 degree each. Ninety by 6 you do, and mark those angles and divide that into equal 6 parts. So continue numbering. Okay, not 1 2 3 4 5 6 in the reverse order how you named in the displacement diagram. It is starting from 6. This point will be 6, 5, 4, 3, 2, 1, and last will be 0. 5, 4, 3, 2, and 1. So this is very important, dividing. Next we will go back to the displacement diagram. Okay, so in the displacement diagram we have to measure this height. Okay, this height we have to measure 1 dash. So first we'll do for 120 degree. In that, measure this distance between point 1 and 1 dash, nothing but this height. Okay, this height you have to measure. What is the height now here? Measuring, it is 2.01, the height. Okay, so the distance is 2.01 here. This software is showing in terms of mm. Okay, so 2.01. So this distance, what distance you got from 1 to 1 dash, that you have to add to this point. So we are doing for 120 degree. So from this point 1, draw a line, whatever distance you got there. Okay, just add straight line. Okay, 2.01 was the distance, that line I have added here. Okay, next we will go to the second one, 2. What is the distance between 2? This is a point 2 and this is a point 2 dash. So what is the distance from 2 to 2 dash in the displacement diagram? Measure that. So now it is showing 7.5 is a distance, 7.5 mm is a distance. So whatever length you get, the distance you get, join this length to the cam profile. So like this, from point 2 extend a line. The length will be 7.5. What length you got there, extend in the straight line. So this initial line what you have drawn and this extended line should be in the same line, the straight line. See here that the length is 7.5 because I got 7.5 there. Repeat that step to all the remaining points. No need of writing that dimension, just for your information I have written that dimension there. Next go for 3.3. Measure 3 dash distance in the displacement diagram. Measure this 3 dash distance. So if I measure, it is coming around 15 mm. So join that 15 in this diagram, in the cam profile diagram. 15 mm. So in the book, if you do in centimeters, it will be 1.5 centimeters. Okay. In software, it is showing in terms of mm. Repeat that for remaining 4 dash distance. Measure the 4 dash distance. It is 22.5 mm. So add that 22.5 to the end of this. It should be in a straight line. Be careful about that. Okay, it looks like this, the lines. Measure 5 dash from the displacement diagram. Join to this point. Last 6 dash distance. From 6 to 6 dash, that is 30. So add that 30 to the 0.6. So 60 degree we didn't do anything in the displacement diagram, so we'll leave it as it is. We'll go to the next section, that is 90 degree. So there you have again the distance, 6 dash distance, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash distance. Measure that and join to these endpoints. How you did in the first case, do the same things here also. Measure 5 dash, 5 to 5 dash distance. So it is showing 28.32. So add that 28.3 to this endpoint. Next 4 dash distance. So marking this intersection point is very important. That's what I told. So you will get the height. 4 dash 23.3 you will get. So join to this endpoint. Next 3 dash distance. 3 dash, it will be 15. So join that to repeat that for the remaining things. 3 is 15. Next 2 to 2 dash distance is 6.63. Add that to this. Last one 1 dash distance. It is 1.66 mm. So join that to this point. Straight line. So be careful. Sorry. Yes. It should not come like this incline. I'll delete that and redraw it. One 1.66 is the length. So see here, it should be in a straight line. Okay, then only it is correct. Okay, this completes extension of the line. Now name the end points. So we have measured 1, 1 dash, 2, 2 dash. So end point name is with the numbers with a dash. So write that numbers here, 1 dash, the end point. Okay, whatever extended, after extending you got an end point. Name those end points, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7. Sorry, 7 is not there. Now next in this again it is 6 to 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, and last 1 dash. Okay, so this completes marking the points. Now join all these end points. Okay, the freehand sketch curve, not with the scale. Just go on joining from starting point. You start from the 0. Next 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7, 6 dash, again 4, 5 dash, 4 dash, continuous. You go on joining all those points. 3, 2, 1 dash, and last two 0. Okay, so this completes the profile. This is how the cam profile looks for a knife edge follower with the radial type of follower. So this is how the profile looks. So the red color one what I have marked, that is the final profile. As coming to the calculation part, he has asked us to calculate the maximum and minimum, sorry, not minimum, maximum velocity and acceleration at both inward and outward stroke. Okay, so for that we need the data. The data we need is given in the question. Okay, so first in the question it is given 1200 rpm. If you see the question, okay, so first using that speed we need the omega value. So this is how you calculate the omega value. Omega is 2 pi n by 60. Substitute that 1200 rpm speed and you will get the answer in terms of radian per second. Okay, so this is required for the remaining calculation, all the data, because I had given you the chart with the formulas, 12 formulas. Okay, those are required here to calculate the velocity and acceleration. Okay, next we will go for outward stroke. So what was outward stroke? That means curve is going upwards, follower is moving away from the cam. That what type of motion we have? SHM. Okay, so outward movement and SHM and velocity. What are the formulas we have? We will use that. Okay, first we will calculate the maximum velocity. So see that chart. So in that chart the formula is VA is equal to pi omega S by 2 theta A. So omega we have calculated here. S is nothing but the displacement, the stroke length. What is the height it is moving, divided by 2 into theta A. Theta A is nothing but the angle, the duration at which this movement taking place. Okay, so that was first part was the outward movement going upwards, it was 120 degree, so that is theta here. Substitute all the values. Pi into omega we got 125.664. S is 3 centimeters, so substitute in terms of meters. Okay, 3 into 10 to the power minus 2 divided by 2 into 120 is the angle 120. Always write that in terms of radians. Okay, so 120 into pi by 180, because here omega is in radian per second, so that radians per, the radians get cancelled. So convert this degree into radians. So 120 into pi by 180, calculate that, the answer will be 2.874 meter per second. That is maximum velocity. So outward stroke, SHM, maximum velocity. Now next is to calculate the maximum acceleration. The outward stroke, SHM, maximum acceleration. See that table. What is the formula? So formula is AA is equal to pi square omega square S by 2 theta A square. So again, all data are available, just the substitution. Okay, pi square omega square 3 into the omega is 125.64 square, 3 centimeter divided by 2 into the theta square. Remember, square is there. So answer is 532.956 meter per second square. So this is for outward stroke calculation. So formula, remember the formula, that is very important. Next, calculation for inward stroke. So inward means the follower is coming back to the starting point, inward movement. So what type of motion we have? It is UARM. Okay, so type of motion is UARM. So in UARM, when it is inward stroke for UARM, maximum velocity, what is the formula? Formula is VA is equal to 2 omega S divided by theta D. That is the formula what I gave in the chart. So 2 into omega into S, all data we have. 2 omega is 125.664, S is 3 centimeter 0.03, in terms of meter you have to substitute, divided by theta. What is the angle? The return taking place at angle of 90 degree. Okay, for a duration of 90 degree. So substitute that 90 in terms of radians. So answer is 4.8 meter per second. Next, maximum acceleration. So formula is theta is pi square omega square S by 2 theta D square. Substitute all the values. Again, same thing. It is 768 meter per second square. This is how you calculate the maximum velocity and maximum acceleration for inward stroke when it is UARM.